Hey everyone, welcome back. Hope you're doing well. In this first lesson from Module 6, Time Cost Trade-off in Construction Projects, we're going to look at the schedule crashing process. Alright, before we dive in, let's take a quick look at what we're going to learn in this lesson. First up, we'll talk about the time cost trade-off problem, what it is, and why we use a technique called schedule crashing to deal with it. Basically, it's all about finding the balance between finishing a project faster and how much that speed might cost us. Next, we'll learn how to tell the difference between crashable and non-crashable activities, because not everything in a project can be sped up. And finally, we'll go over a common method to optimize a project schedule, keeping both time and cost in mind. By the end, you'll understand how to make smart decisions when it comes to adjusting project timelines without blowing the budget. Alright, let's talk about the time cost trade-off problem. Imagine this scenario. Based on the initial project plan, the estimated duration is 1 year, which lines up perfectly with the contract period. The total estimated cost is $1 million. Now, here's the twist. The contract includes an incentive clause. For every day the project finishes ahead of schedule, the contractor earns a $5,000 bonus. So the project manager is now asking an important question. Is that bonus enough to make it worth finishing early? Is it worth the extra effort and cost? Because here's the trade-off. To earn the bonus, the team would have to shorten the project duration, maybe by working overtime, hiring more labor, or fast-tracking tasks. But all of that can increase costs. And if the extra cost ends up being more than the bonus, well, the incentive loses its value, and that's the heart of the time cost trade-off problem. How do we balance finishing early and saving time without spending too much money doing it? To solve the time cost trade-off problem, it's important to understand how project duration affects two main types of costs: indirect costs and direct costs. Indirect costs, also known as soft costs, generally increase as the project takes longer to complete. This is because these costs are tied directly to time. Examples include overhead, insurance, equipment rentals, and taxes. These costs are charged daily or monthly, so the longer the project runs, the more money is spent on them. Direct costs, sometimes called hard costs, behave differently. These include things like labor, materials, and equipment used directly for project tasks. When you try to shorten the project duration, direct costs tend to increase. This happens because speeding up work often means paying for overtime, bringing in extra workers, or paying premiums to fast-track deliveries. However, if you stretch the schedule and allow more time, the work can be done at a regular pace, using standard work hours and typical crew sizes. In that case, direct costs stay lower per day, but are spread across a longer time frame. Now, when you combine both indirect and direct costs, you get the total project cost. What's interesting is that this total cost is high when the project is extremely short or extremely long. In fact, it usually forms a curve, where both ends, very fast and very slow, are more expensive. The goal is to find the ideal duration where the total cost is minimized, and that's the ultimate goal of the time cost trade-off problem. Again, direct labor and overhead are crucial factors in setting the project timeline. However, there are several reasons why a project team might choose to accelerate the schedule. One common reason is financial incentives, such as bonuses offered for early completion. These rewards can motivate teams to finish ahead of time. In some cases, it's about avoiding penalties. Many contracts include fines for delays, so finishing early or on time can help steer clear of those extra costs. Another factor could be client urgency. Sometimes the client has pressing business needs or public commitments that require the project to be completed sooner. Resource availability can also play a role. If there's temporary access to extra labor or equipment, it might make sense to speed things up while those resources are available. Weather conditions are another key reason. In some regions, it's important to finish work before the rainy season or winter begins to avoid complications or delays. Completing a project early can also strengthen the contractor's reputation, showing reliability and efficiency, which is valuable for winning future contracts. In some situations, accelerating the schedule can even lead to cost savings. This might happen by reducing overhead costs or avoiding price increases due to inflation. And finally, improving cash flow is another incentive. By finishing earlier, teams can issue invoices sooner and receive payments faster, helping to maintain better liquidity throughout the project. There are several methods that can be used to accelerate a project schedule. The first is to change the construction logic. This might involve increasing lead time for procurement so that materials arrive earlier, or adjusting the workflow to allow certain activities to run in parallel. This approach, often called fast tracking, can help reduce delays by overlapping tasks that were originally planned to happen one after another. Another method is to use alternative construction techniques such as prefabrication. By building components off-site while other work continues on-site, prefabrication can significantly shorten the overall timeline. The third option is to reduce the duration of critical path activities, a strategy known as crashing. This can be done by assigning more resources to key tasks or by using overtime to get the work done faster. While these methods can help speed up progress, it's important to weigh the potential benefits against the added costs and risks they may introduce. In this lesson, we're going to focus specifically on the schedule crashing method as a way to solve the time-cost trade-off problem. Now let's talk about schedule crashing. This is the process of shortening the overall project duration by reducing the time it takes to complete one or more activities, especially those on the critical path. There are several ways to do this. One common method is to add more workers to a task. This is also known as crowding, which can cause reduced efficiency if not managed well. Another option is to introduce extra shifts or extend working hours by using overtime. In some cases, teams might even work on days that were originally planned as non-working, like weekends or holidays. Crashing can also involve changing the way equipment is used. For example, bringing in more machines, switching to larger or more efficient models, or upgrading to better performing tools to speed up the work. Each of these strategies can help compress the schedule, but they often come with trade-offs in terms of cost, so they need to be applied thoughtfully. When it comes to schedule crashing, it's important to understand the difference between crashable and non-crashable activities. Crashable activities are the ones that can be shortened by adding more labor, bringing in extra equipment, or extending work hours. These are typically tasks where increasing effort directly leads to faster completion. On the other hand, non-crashable activities are those that can't be shortened, no matter how many resources you throw at them. This might be because they rely on external factors, such as waiting for permits or approvals, or because they involve processes that simply take a fixed amount of time, like allowing concrete to cure. So, when you're looking to speed up a project, it's crucial to identify which tasks can realistically be crashed. All right, let's walk through the schedule crashing procedure step by step. First off, we need to identify which activities can actually be crashed. Not every task on a project is flexible. Some simply can't be shortened no matter what resources we throw at them. So our first job is to pinpoint the ones that can be shortened by adding people, working overtime, or using better equipment. Next, for those crashable activities, we figure out their minimum possible duration. That means asking, if we push this task to the limit, how fast could we realistically get it done? After that, we calculate the maximum crash duration. That's just the difference between the normal time it takes and the shortest time we just figured out. Once we've got that, we calculate the cost of doing the task the normal way and the cost of doing it as fast as possible. Those are our normal and maximum crash costs. Then comes the unit crash cost, which tells us how much extra it costs to reduce the duration by 1 unit, say 1 day. That's the crash cost per day, and it's a key number when we're figuring out whether crashing makes financial sense. After all that prep, now we look specifically at crashable activities that are on the critical path, and we prioritize the ones with the lowest crash cost per unit of time. That's because we want the biggest schedule improvement for the lowest price. Once we pick the best candidate, we crash it by 1 unit. So maybe we shave off a day. Sometimes we may need to crash multiple activities at a time in order to reduce project duration by 1 unit. Then we calculate the total cost of that crash and compare it to the benefit. If it ends up costing more than we save, then it's not worth doing, and we stop right there. But if we're still saving money or time, we move on. At that point, we recalculate the entire schedule. Why? Because crashing one activity might create a new critical path. So we need to check if something else becomes the new bottleneck. And finally, we repeat the process. We go back to step 6, pick the next best crashable activity, and continue until we either hit the minimum project duration or it's no longer cost effective. All right, that wraps up this video where we explored the key concepts behind the schedule crashing process. Thanks for watching, and I'll see you in the next video. Goodbye.